All right, let's look at the second part to this problem. Let's say we're going to go around the same curve here. Let's take friction out of the problem here. So we're not going to have any friction. Instead of friction, we're going to bank the road. We're going to angle it up. All right, so if that's the case, and we're angling this road up, and we're not going to have any friction, what we're going to do is rely on the force of the road to push the car in towards the center. Okay, so we're going to need a force of the road here, and that's going to be angled now. And so there will be a component of that force that pushes the car in towards the center on account to create that normal acceleration. So let's see what the angle should be if we don't rely on friction at all. So what we're going to do is relate that force of the road, and particularly its component in the x direction, to the normal acceleration. Okay, so we can find the weight. It's the same as above. Normal acceleration is the same as above on your page there. But now let's start to figure this out with the angle and that normal acceleration. So I'd like to see, if we bank the track, which way does the acceleration act, this normal acceleration? Is it parallel to the track? Is it horizontal, or is it normal to the track? So think that through a little bit. I mean, really what you can kind of think of that car as traveling around the inside of a cone, and we want to know which of those three directions does the normal acceleration act. So maybe give that a little thought. If need be, just pause the recording for a second and think it through and see what you got, then we'll go over that. All right, so the deal with this is the car, even though it's banked, is going around this horizontal circle. The normal acceleration acts in towards the center of the circle on this axis. So it's this one, okay? Even though the car is angled, it's still traveling in a horizontal circle. So it acts in towards the center of the horizontal circle. So the normal acceleration is horizontal. All right. So now here's our free body diagram. We don't have any friction, so we got the weight down, the force of the road, and then the normal acceleration. Now we're going to work through a series of equations to figure this thing out. I think we do want to look at this and again make a decision. Which equation would we start with? You know, I think we kind of want to start with what that road force is. And which one of these two equations would get us the simplest answer and the simplest expression for the road force? So maybe, again, have a look, pause the recording if you need to, think it through, and see which equation you would use. All right, now here's the deal with this, this one. When I'm finding the force of the road, I really don't want this normal acceleration in the expression. Okay, so even though I'm on a banked track and I tend to want to use an axis system like this, on this particular problem, I don't think I would. I think I would stick with just a straight sum of Fy equals 0. The reasons for that is, one, the acceleration is horizontal. So if I go with an angled sum of Fy prime, I'm going to pick up a component of that acceleration in the equation, which is going to make it more complicated. So I'd prefer to avoid that. Okay, so if I just go sum of Fy equals 0, I will not pick up a component of the normal acceleration. I'll have a much simpler equation. The other reason to do that is I don't have any friction acting on this, mu 0, so there's no friction. So I don't have a component of force parallel to the ramp there. Okay, so I don't need to worry about these inclined axes quite so much on this problem. It's simpler just to use a straight up XY axis. Okay, so to get an expression for the force of the road there, I'm just going to go sum of Fy equals 0. All right, so when I do that, I'm going to have cosine of that angle. We went over that in the last session there, where this force normal to the road would make an angle of theta, which is this ramp angle with the vertical here. So cosine theta, cosine of that angle, times F road will get me that component that goes up in the y direction. That'll be up, and then I've got the weight down. And I've got a little bit of a typo here. This ought to be a 7, I think, as should this, of course, just a typo. So that's going to work out to cosine theta f rho is 11,772. All right, so that's one equation that I've got. Now the other thing I'll do, I'll just go straight sum of fx is max. I do have acceleration in that direction, so it's an f equals ma equation. I'll call left positive there. And what I'll get out of that is that sine theta times f rho, that'll get me this component going this way, basically. Okay, so sine theta f rho, that's the force, and that'll equal the mass times the acceleration. When I work that out, that's 4164 is sine theta. So I got two equations with two unknowns. Unfortunately, I've got some trig in here, which makes that a little bit difficult to solve. But there's a nice little trick I can use. What I can do is just divide the equations. I can take sine theta f rho is a 4164, divide that by the cosine theta f rho, and divide the 4164 by the 11772. And then what I get is these f rho's just cancel. And what I get is sine theta over cosine theta, and that's tangent theta, and that's 0.354. So that angle for no friction should be 19.5 degrees. Okay. All right. So that's how I could work that out. Now, one thing I'll point out is that 0.354, see, that's the same coefficient of friction that we got up here. That's an interesting little relationship that you might see down the road. May not, but you might, so notice that, okay? So that bank, the slope, which is the tangent, I guess, is equal to the required coefficient of friction. All right, so some homework to be doing for Monday, I guess it would be. Not 191, 192, 193. And I think we're going to have a midterm here on Monday the 29th. So be aware of that, okay? So that midterm will be Monday the 29th. And then our the homework due is these three problems. Now, if you're online, I'll probably have a time in the evening if you want to come by here. If the normal exam will be at about 3 to about 4 in the afternoon for the in-class students. If you're an online student, you can't make it at that time, I'll have an evening time when you can come in. You could also have the test proctored at an accredited school. Quite often they have testing centers. If you're going to do that, take care of that early. They often require advance notice on that. They might require a fee. So, have a look and see how that might work for you if you can't come in either at 3 or in the evening.